Hello, and welcome to another episode of South Pole, the podcast that explores all things Antarctica. I am your host, Clark Marchese, and today we are talking about the fascinating world of parasite-host interactions, elephant seals, and marine lice. All right, hello everyone. We have made it to episode 10, which is in fact going to be the last episode of this first season of South Pole. We've covered quite a range of topics on the show so far, from bird flu, poetry, to toothfish, and historical exploration. Today we're adding one more interesting topic to the lineup, but don't be too sad because we have another 10 equally diverse range of episodes coming out in season 2 in just a couple of weeks. So make sure you stay subscribed to the show so you can get notified when they drop. All right, into the topic for today. We are going to do an episode on elephant seals at some point, but today is not that day. They are only tangential because today we are interested in the lice that lives on and burrows into their thick fur coats. Our guest for today is Dr. Soledad Leonardi, a researcher at the National Research Council in Argentina. Dr. Leonardi is a parasitologist who focuses on the interactions between seals and seal lice, and her research explores the coevolution of these two species, disease transmission, and how parasites have adapted to the extreme conditions of the Antarctic environment and the deep Southern Ocean. Today, we'll focus on how coevolution shapes the interactions between seals and seal lice. In the episode, we'll discuss how coevolution shapes the interaction between seals and seal lice, how the lice have adapted to the process of molting, how they can survive when seals dive 200 meters below the surface of the ocean, and how they have lined up their reproductive schedules with one another. With that, let's go ahead and get started. All right, well, Dr. Leonardi, welcome to the show. The first question I have is if you could just introduce yourself and tell us a bit about your research.
Yeah, thanks you for inviting me. I'm Soledad Leonardi. I'm a researcher at the National Research Council in Argentina. I live in Puerto Madryn in Patagonia. My research focuses in the coevolution process of lice from seals and sea lions.
So today we're talking about parasites, and not the Oscar-winning film from South Korea. We are talking about seal lice. As a scientist, what sorts of approaches do you take in studying this type of insect?
Yes, well, I'm a parasitologist, so I study the relation between parasites and hosts that are closely related, especially in the case that I'm studying that there are these parasites that were present already when the actual pinnipeds were terrestrial carnivores, you know? So they go together in the evolution colonizing the sea. It's a process that involves both the lice and the actual pinnipeds. So it's a very interesting question because most of the parasites of these Antarctic animals extinct when the pinnipeds colonize the sea, but lice will survive.
Okay, parasitologist, that's such a cool ology. And another ology word I've seen associated with your work is evolutionary biology, which is a broad-based approach that looks at how species originate, change, and diversify over time. And I guess you just gave us a great example. As the seals moved into the marine environment, the lice were able to adapt and evolve with the seals, but some other parasites were not. I'm curious if you can tell us why it's important to study biology from this evolutionary point of view.
I think that is because it's a way to understand our world. It's the basis of any biological study to understand the evolution and the processes, especially I think in this context of climate change that everything is changing so fast. I think that is fundamental to understand the evolutionary processes.
So, seal lice, that's a very specific niche and very interesting from what I've read so far. What made you interested in studying seal lice in the first place?
Well, in fact, first I was interested in the host because seals and sea lions are amazing. And then I discovered that they were infested with lice. And I started reading about lice. And it's very curious because there is very little information about sea lice, but they're so amazing too.
And so these species are technically an insect, if I'm correct, but they live partially in the marine environment, which we do not see often. Can you tell me a little bit about that?
Yeah, because as everybody knows, insects are the most successful group of animals in Earth. Both evolutionary and ecology and are the most abundant and the most diverse group of animals. They are present everywhere except in the biggest environment that is the sea. And it's very curious because a group of animals will adapt to so many conditions are absent in the deep of the sea. Most of the species live on the surface of the sea. So the only species that actually live under the sea and are exposed to truly marine conditions as salinity, low concentration of oxygen are the lice.
Do seal lice exist only in the Southern Ocean ecosystem, or are they throughout the rest of the world?
They're present in every species of seals, in the walrus and sea lions. They're present in all the species of pinnipeds.
Okay. And to understand the evolutionary biology of these two species, have they always been able to thrive in the marine environment, or is that something that came along some point throughout their evolution?
Now, many years ago, they were a kind of a carnivore, similar to an otter or something like that. And they evolved in these marine forms in a process that took a lot of years to colonize the marine environment, with the particularity that make the difference between other species of marine mammals and dolphins or cetaceans. Pinnipeds remain with the terrestrial period in their life cycle, They need to go offshore to reproduce, to rest, to molt. This particularity is that made possible that life survive because they need also this time ashore. This is a process that is called coevolution.
Okay, we have another vocab word. Coevolution is the process by which two or more species reciprocally influence each other's evolution through sustained interaction. Now, this interaction can be mutually beneficial sometimes, or it can be what we call antagonistic interactions, such as predator prey, or in this case, parasite host. Maybe we should also define parasite host dynamics. This happens when one organism, the parasite, lives on or in another, the host, and sustains itself at the host's expense. But then, since we're talking about the interaction between species, can you tell us a bit about the interaction between seals and seal lice?
Well, in fact, it's curious because lice use the seal as host. So the seal provides the environment in some way for lice. We are studying if lice, because this particular group of lice are hematophagous insects. That means they eat blood. No, they are blood feeders. It's a characteristic from hematophagous insects that they can transmit diseases. So we are studying if, in fact, sea lice also act as vectors of some diseases to seals.
We just did actually have an episode on wildlife diseases with Antarctic birds, and we've seen, I guess, in the worst case scenario, some mass mortality events. So, can you tell us perhaps just how important seals and pinnipeds are to the Antarctic ecosystem?
Yeah, they are considered top predators. They are on the top of food webs together with killer whales. So they're also, we call them sentinels of the state of the environment, because if we can detect that something is wrong or is changing with these animals, it's a clue that is changing the entire environment. Because in this chain or in this web that is connected, since krill to seals, any change in this web affect the final, that is the top predators.
Are we seeing that the seal lice are having a negative impact on the ability of seals to fulfill their ecosystem function?
Well, we don't know. It depends if they actually can transmit some diseases. It's very interesting because last year, for example, there was this epidemic of avian flu that caused a lot of deaths, especially in Patagonia, of sea lions and elephant seals. And we don't know, for example, if lice are infected with this kind of virus. But in this context of climate change and the diseases that appear, maybe lice play a particular role. We don't know yet.
Okay. And I guess it's only fair since I asked about the seals. So, do the seal lice play any important role in the ecosystem?
Yes, I defend the parasites, because the people think that parasites are something that are wrong or that cause the damage or diseases. But in fact, if we think about it, being a parasite is most common than being a free living animal. If we think that every animal on Earth are infected by at least one species of parasites, is most common and most abundant, the parasites. So they are a fundamental component in the nature. Maybe we can't understand because we see the parasites as something that are wrong because they cause diseases on us too. But for nature, there's a mainly component.
Okay, interesting. Well, you won't find any speciesism on this podcast. There's a couple questions I want to ask you about some articles that you published. One worked on investigating how seal lice are responding to molting. So, first, can you maybe tell us what molting is, and then also what you discovered about seal lice and what they do during that process?
One of the main features of mammals is that they are covered by hair. Hair is something that they need to change, especially in seals, and there are different kinds of molting. The particular case of elephant seals is that they remove not only the hair, but also the first layers of the skin. So imagine that if the lows live on the surface, they can disappear with the skin. So the life from elephant seals have the particularity that they burrow the skin and put under the skin to be protected during this molting.
Okay, so that's another example of coevolution, even if it's a bit creepy, but we will still defend the parasites where we can, I guess. The other article I want to ask you about discussed the coevolution of seals and seal lice having to do with their reproductive cycles. Can you explain what this article worked on?
Yes, because lice can survive underwater, but there is a main restriction that is related with the fact that eggs don't survive underwater. So for reproduction, lice need to stay enough time ashore to guarantee the development of eggs. This time is the same that use the host to reproduce. So there is a coordination between them. When the hosts go ashore to reproduce, is the window of time in which lice can do it too.
Okay, that's fascinating. And I guess I'll ask the same question. Is this a recent behavior or have we seen this happening for a long time?
No, I think that is a consequence. It's a consequence of this co-evolutionary process, and it's the key that allow the lice can survive. They only survive in species that remain with a terrestrial phase in the reproductive cycle. Because, for example, baleen or whales and dolphins also have a terrestrial origin, and maybe the terrestrial forms were infested with lice, but they evolved and completely marine mammals, so they lost the hair. And if they have some lice species, they die on extinct, during this process.
What other kinds of things do we still need to look into? Are there any other burning research questions when it comes to sea lice?
Well, we are studying now. For example, an elephant seal can reach more than 2,000 meters diving, and it's a lot of pressure, you can imagine. And they also spend several months at sea. So lice remain submerged for so long without oxygen to breathe. So we are studying how it's possible to see lice to survive under these conditions. And we found, for example, that they can actually obtain some oxygen from the seawater.
Wait, like fish do?
Yeah, so we don't know the mechanisms they are using to do that, but it's something that we are working now.
I'm also curious because climate change is a process that's going to put a lot of species under pressure to adapt quickly. I'm wondering, are there any current or future concerns with how sea lice or the relationship between the species will evolve as temperatures rise?
Another interesting thing about lice is that because they are insects, there are many changes that we can see now in lice that we use as a proxy of some situations that I live in the marine mammals, the seals, especially in a context of climate change. So maybe we can use some information from lice to understand what is happening with seals in a process that maybe take a lot of years to seeing the consequences on seals.
Okay, I guess that's just another area we just have to watch this space. Well, as we start to close out the episode, I want to ask if there's anything else you want to add that we didn't mention, either about seals, seal lice, or research in Antarctica more broadly.
Another thing that is important that I think to related to Antarctic research is related with how difficult it is to women to make Antarctic science. So when I traveled to Antarctica before my child, it's a lot of work to women that continue working in Antarctica because the field work takes a long time. They're months working in a very isolated place in the world. So it's complicated. And there is a little thing that I want to comment that is, well, we are Argentinian scientists and we are living a very particular situation now in Argentina because we are with a government that is making cuts in the budget and is against the science. So it has been complicated to make science in Argentina now. Also, the Argentina and Antarctic Research Program is in risk under this government. So I think to remark the importance of the government support to these programs.
Well, thank you for sharing that. And I guess in that effort, where can people find you and follow your work?
Well, they can follow me on Twitter, where it's a place where I share our last research and news and our work in general.
Okay, well, listeners will be able to find that in the episode description. And with that, I want to thank you so much for your time today. Thank you for teaching us about seal lice and also for your very important research.
Thank you for inviting me. It was a pleasure.
All right, the end of this episode also brings us to the end of season 1. I want to say thank you to all of you who have listened and followed along with the show, and I want to thank all of the amazing guests and scientists that have given their time and shared their research with us. I had such a fun time making this series, and spoiler alert, I've also had such a fun time making season 2 already, which will feature 10 more episodes on this Antarctic exploration, so stay subscribed and hold tight because they are coming your way soon. All right, kisses, and we'll talk soon. You've been listening to South Pole. You can find more information about this week's guest and links to their work in the episode description. Cover art for the show was done by Laurel Wong, and the music you're listening to was done by Nila Ruiz. I am your host, Clark Marchese, and this episode was produced and engineered by me. So if you found it interesting, send it to someone you know. South Pole is part of a larger network of sciencey podcasts called Pine Forest Media. We've got one on plastic, one on drinking water, and a couple new ones coming out soon. You can find more information about us in the episode description as well, or at pineforestpods.com. We are also on Instagram and TikTok at Pine Forest Media, and if you love the show and you want to support science communication like this, a 5-star rating across platforms and a review on Apple Podcasts is one of the best things you can do to help us reach more people and for the entire network to grow. All right, thank you to all of you who have made it this far, and we'll talk soon.